This is the graph of our parent rational function, which is 1 over x. But if we're going to make transformations, we want to start thinking about the transformed version, which looks like this and has a's, h's, and k's like we've seen before. If we need to translate our graph to the left or to the right, we do that in the denominator next to the x. Normally we would see this inside parentheses where x is a liar. If we want to move it to the left, it has to be minus a negative, which is what makes it look positive, and that's why we say x is a liar. If we want to translate it to the right, we do x minus a positive in the denominator, and that will move it to the other side. When we're moving or translating left or right, notice that there's always this space in between. We'll mark that here. We can mark that as x equals h. We'll make that one a different color. We'll make that one green so you can see it. All right? So whenever I move it left or right, there's this line, this invisible fence that the graph will hug, and that's the vertical asymptote for our parent rational function. If I want to translate it up or down, I have to change it outside, adding or subtracting outside for my vertical translation. And I'll move it down by subtracting a number, outside, and up by adding a number, outside. Notice the vertical asymptote stays exactly the same place because we're not moving it left or right. There's also a horizontal asymptote, and that's at the line y equals k, and we're going to make that one pink so you can see it, so that when we do translate up or down, that there's a horizontal fence that it'll never cross as well. And then finally, we've done translations left and right, translations up and downs, and the last thing we want to cover is vertical reflections and vertical stretches. If I multiply, if I make my numerator a big number, I'm going to be stretching my graph. Notice the asymptotes stay exactly where they are. Now I'm going to make it smaller. Now if I multiply by a number that's a fraction, less than 1, that's going to be a vertical compression, and it starts to squish in. Now something's going to happen when I get to a equals 0, because that would make it the whole thing go away. It turns into a straight line. When we go to the negative side, boom, it flips over. It's reflected, vertically reflected. This line here has flipped up to that line there. Everything is flipped over the y-axis, and now we're being vertically stretched and reflected over the y-axis. Notice the asymptotes stayed exactly where they were before. Let's go back to where we were. We're gonna reflect back to our original position. And that's what the graph of rational functions looks like, and how we transform it using our a, h, and k as we've done before.